Hello and welcome to another session in physics. In this session we'll be looking at the topic alternating current, and we'll be looking at the first session of this topic, alternating current. Seeing that this is a fresh term, let's go through the definition of alternating current circuit. But when we talk about alternating current, we simply mean current that flows in an alternating manner. The English word alternating means to variate. Alternative means to variate. And when we say something is alternating, it means it is not steady. Alternatively means we have options. It doesn't just go in a single or in one straight line direction. It is not steady. It is not single, it is multiple. And that is the idea we want to propagate in our study of an alternating current circuit. That is an AC circuit. Now, as you can see from the slide here, an AC circuit is an example of a circuit through which alternating current flows. I'd like to make it clear that AC circuits are opposite of DC circuit. An AC circuit, the current in it flows in a sinusoidal manner, as we will see later in this lesson. Sinusoidal means it flows in a sine wave form. A sine wave form means it rises and it falls. It rises and it falls. It does not go straight or steady just like a DC. A DC is steady current, flows in one direction. But AC has the capacity to vary its direction. And that is why such circuits are used extensively in power transmission. They are used extensively in radio and television technology, in computer technology, in telecommunications, and in medicine. Like we've already said, it varies sinusoidally, or it varies periodically in such a way that it has the ability to reverse its direction. That is what an alternating current is. Now think about this. If we were to use DC current in our houses, we would only be able to power one appliance or a single appliance at a time. Probably when you want to iron your clothes, you will just have to iron, and then you would not be able to watch TV at the same time as when you're ironing, because you would need the DC to power the iron only. And then if you wanted to watch TV, all other appliances would be off, so that after watching the TV you could come back to do any other things, such as operating the washing machine. But then alternating current came to our rescue and makes it possible for us to use many appliances at the same time. No wonder its uses are so vast and cannot be overemphasized. Now, the commonest form of such AC circuit can be represented using this equation, where we have something like this: I equal to I subscripted O, here this is O, then we have sine 2 pi ft. Alternatively, we can also have I equal to we have IO, and then we have sine angular phase. This is omega. Then for the voltage, we can have something like this. We can have V with subscripted O sine 2 pi ft. Then we can also have V equal to V with subscripted O sine angular phase. Any of these formulas can be used to find AC, which is alternating current, or AV, which is alternating voltage at any point in time. This is alternating current, and the other is alternating voltage. So let's try to explain what these terminologies are. This I you see here that does not have O beside it is called the instantaneous value of the current. Instantaneous current. And then we have the I with subscripted O beside it. This is the peak value of the current. And then we have V here, which is instantaneous voltage. Instantaneous voltage. And then we have the V with O beside it, which is the peak value of the voltage. Another name for the instantaneous current is called RMS current. The RMS current is the direct value of the current, and this one is also called RMS voltage. RMS means root mean square, as we will see in subsequent lessons. It is the equivalent of the direct current found inside the AC. You see, the fact that it's called an AC does not mean it does not have an element of direct current inside it. It also has an element of direct current inside it. And then we have 2 pi ft. 2 pi ft is the angular phase of the current, or what we call phase angle of the current. It is the same thing as this. It is still the same thing as this. So you can either use this or this to show the angular phase of the current, so the phase angle of the current. Then the sign here means that it is an angle. Of course, sign means an angle, means there's an angle involved there. Now let's try to find the answer to this question. It says that if an AC voltage is represented by V equal to 4 sine 900 pi t, we're asked to calculate the peak and instantaneous voltage. So let's try to find the answer to this question. Well, we know from the equations we wrote earlier that we have V, a peak value of the voltage, which is after that you have sine 2 pi ft, and then we also have V equal to VO sine angular phase. Well, what this means is that looking at this equation critically, you know that the one that comes closest, the similar one here to this equation, is the first one. So we're going to equate where we have V equal to VO, the peak value of the voltage. This one is the instantaneous or RMS value of the voltage. Then we have sine 900 pi t. So we're going to divide this from here. We're going to divide from this point. So equating, we have 2 pi ft equal to 900 pi t. So we're going to try to make f the subject of the formula so that we can find our frequency. We have 2 pi t, 2 pi t. So 2 pi t will cancel 2 pi t, 2 pi t will cancel 900, giving us 450 pi times t respectively. So we have our f frequency equal to 450 Hz. This is our frequency. But what is our peak value of voltage? Peak voltage, which is this, is given as, watch very well, you would see that we have from V equal to VO sine 2 pi ft, we have V equal to, watch here, the corresponding number according to the equation is 4 sine 900 pi t. Alright, so watch here, the peak value of the voltage is 4. So therefore, the peak value of the voltage is equal to 4 volts. That is the answer. And then what about our instantaneous voltage? Our instantaneous voltage, or our RMS voltage, it is given by peak value of the voltage divided by root 2. Peak value of the voltage divided by root 2, which gives us instantaneous voltage equal to peak value of the voltage is 4 divided by root 2. Applying the principles of SOD, we're going to have 4 over root 2 times root 2 over root 2. At this point, we're multiplying, we are rationalizing by multiplying both the numerator and denominator by the SOD part of the denominator. So we're going to have here 4 root 2 over root 4, because root 2 times root 2 is root 4. And then we're going to have 4 root 2 over 2. The square root of 4 is 2. 2 divide 4 is going to give us 2. So therefore, our final answer, instantaneous voltage, is going to become 2 root 2 volts. Alternatively, you can use a calculator and find the answer in a way that is not so. Now, when we talk about alternating current or alternating voltage, like we've already said, it varies sinusoidally, as you can see from the diagram here. It rises and it falls. It is not steady at all. Then the root mean square, the RMS value of the current, is the effective value of the current. It is that steady current which will develop the same quantity of heat in the same time as the resistance. The RMS value of the current is given by peak value of the current divided by root 2, similar to the RMS value of the voltage. Now let's talk about the hot wire instrument. The hot wire instrument is an instrument that helps us to measure the RMS current directly. That is the way it has been designed or calibrated. Most AC meters read the effective or RMS values, and one of those meters is the hot wire instrument, as you can see from the diagram here. It's made up of a scale, meter terminals, phosphorus bronze wire, and a spring. It's also important to note that the average value of an AC voltage is equal to 0. Thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.